In this video, we're going to be solving this problem on compound interest and exponential functions and formulas in Algebra 1. The problem statement says, Harvey borrowed $2,000 from his dog at an annual interest rate of 5% compounded monthly. How much does he owe, including the original $2,000, at the end of 3 years? So to solve this question, we're going to need to apply the compound interest formula, and this is a formula that is kind of closely related to exponential functions and how they're defined. So here's the formula. We're going to dive a little bit deeper into this after we've got the formula written down here and discuss what these components mean. So here's the general formula we're going to use. So in this formula, this P sub 0 is the principal, it's what we're starting with. In this case, $2,000, the value Harvey is starting off with at the very beginning of this whole situation. Then we have the R value here, and this R is the annual rate that Harvey's going to have to pay to his dog. So he's paying an annual interest rate of 5%, and that's going to be the rate. So the rate is 5%, or 0.05. And N, in this case, is the frequency of the interest payment. So since Harvey is compounding this 5% interest monthly, it means that he's going to pay that 12 times within 1 year. So that means our N must be equal to 12. So, and then the final value up here, T, is multiplied by N. And T is basically how many times or how many years he's going to be doing this payment, which is 3 years. So it would be 12 times 3. So let's go ahead and fill this in with all of our values. We know P is 2,000. Write that in. Then 1 times 1 plus the annual rate, which is 5%. We're going to write that in decimal form to make it easier. Over the frequency of the payment in 1 year, which is 12 times. Then we multiply that by 3 because he's doing this for 3 years to get to the 36. We're raising that to the 36th power there. So this is our completed and filled in formula here. Now, please note that in order to fully solve this and get to an approximated or rounded answer, you're going to need to use a calculator. So that's probably the main challenge here. It's not really the challenge, but more like okay, you're not really going to get an exact answer. You're going to get a repeating decimal, which you're going to want to round using a calculator. So you would probably have to use a calculator app to multiply this through, making sure you put in the parentheses to get the correct order of operations. And then you'd want to raise that to the 36th power to get to your answer. And the actual answer would turn out to be $2,322.94, and that's going to be rounded to the nearest cent there. So that's the result you should get after working this formula through with a calculator, and you can see it makes sense at a glance because it's slightly more than 2,000. You've got 0.05 over 12, you're adding that to 1, so it's going to be a little bit more than 1, so 2,000 times something a little bit more than 1. Then that little bit more than 1 value is raised to 36th power, which is going to make it even more. It's going to be not quite 2, but still in between 1 and 2. So it makes sense that it's going to be 2,322.94 as the final answer. But in this video, we basically went over the formula and the process for solving the problem. So that's how you would solve a compound interest and money question like this, using the compound interest formula we discussed here by filling in the values for the rate of payment, the frequency of the interest payment, and the time, and the starting value, or the principal. This was a compound interest and money question in Algebra 1 and exponential functions.